Welcome to Study Loop.
In this problem, where you are asked to use the bond enthalpies listed in Table 8.4, which I'm going to reference, to find the molar enthalpy change for 3 different situations. I'll do each one separately. The first is polymerization of ethylene. Okay, so for the polymerization of ethylene, let's start by just showing real quick what that is. And this isn't going to be too beautiful here, but here's ethylene. And we're talking about the polymerization. Oops. So that is what we're talking about right here. And let's remember that when we're using bond enthalpies, what we're going to do, I'm just going to write this as a reaction now. Let's switch colors. That I've got H2C double bond C H2 is going to H2C H2. And we find our formula, our heat is going to be equal to reactants and this equation will be the same for all. Okay, so let's look at our bonds. And our bonds right here is we have 4 CH bonds, and here we have 4 CH bonds. So those will cancel out. Here we have 1 carbon, double bond carbon. Here we have 1 carbon, single bond carbon. When we get to table 4, I can ignore these. I'm going to highlight those that I can ignore. Actually, I'll highlight those that I can use. I'm going to use those. There we go. So we are going to check this out, and I will get this will be equal to 614 kilojoules per mole minus let me double check here. I think I did my original calculation wrong. Hang on. I'm not starting over because I got too much time in this. CC let me look again at my bond energies here. I'm going to try one other different thing here. So in this, I'm going to have, I got to write this down because I'm thinking out loud right now. 4 CH bonds plus a C double bond C, and subtract from that 4 CH bonds onto with 2 CC bonds. Okay, so now I can do this. These will still cross out, and I'm going to end up with 614 kilojoules per mole minus 2 times 348 kilojoules per mole. And these values I just looked up in a table. And we get negative 82 kilojoules per mole for our first substance. Okay, our second substance is B, formation of nylon 6,6. should do a comma there. Formation of nylon 6,6. So this one is, I'm going to try to write this one, and I had to look this one up. Up, down, up, down. Okay, so that's our nylon 6,6. And this is, again, I had to look this up because I didn't know what this was. This is hexamethylene diamine. Okay, so we're looking at this. Again, we're going to have to do all of our steps. So this is going to be a little bit harder. And you can look at this and come back to it if you want, but I'm going to go to the next page so I have enough room. So we got all of our differences for our products here. And I'm just going to try to get all of these written down. For a reactant, we have 20. I'm going to move over a little bit. CH bonds. Four NH bonds. 2 CN bonds. 12 CC bonds. 2 C single bond O. 2 C double bond O. And 2 OH bonds. And for the products, we have 20 CH bonds. We have 2, I think I wrote this one wrong, NH bonds. We have 3 CN bonds. Trying to make these sort of work here. I should have done some lines. For my CC, I have 12. My CO, I have 0. So I've got 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. I have 2 C double bond O. I have 4 OH bonds. And I have another CN bond to link to the adjacent. One more CN to link to the adjacent monomer. Whew. So we have to do all of these. So I'm going to cross out some of these. And let's cross them out with pink. Cross out those two. For the NHs, I'm going to end up with 2 NHs on the reacted side. Let's write this down. 2 NHs. And here I have 1 C double bond N. Actually, I'm going to make that 2 because I forgot that. Whoops. Forgot my 2 right here. 2 of these. Then let's get down to, those are good. Here I have 2 C bond O. And here I have two OH bonds. So let me see. Do I have two of these? And two of these? Two of these and two of these. Okay, so there I am. That's everything that I need now. I can look up my values. Switch colors again so you can tell I switched. This will equal products, which will be I might have done this wrong over on this side. Was it products minus reactants? No, I did it right. It is reactants. Yeah, that's right. I did it right. Don't worry. I just had a momentary glitch there. Okay, so this one is going to be 2 times our NH, which is 2 times 391 kilojoules per mole plus 2 times negative 293 kilojoules per mole. Let me get back to a different problem here. I want to make sure I've got the right values. Okay, 2 times 391. And then my next one is going to be 2 times my C double bond, or C bond O is 358 kilojoules per mole. And I'm going to subtract from that 2 times, I'm going to leave my units off, they're all kilojoules per mole. So all kilojoules per mole. Which is, this comes to negative 14 kilojoules per mole when I add those all together. Whew, that was a toughie. Next, we've got the formation of polyethylene terephthalate which is PET. Another one I thought, seriously, how am I supposed to know this? So the whole PET, fortunately, we had this. So it's going to be ethylene glycol. I'm going to do another bad diagram here. Okay, and this is our PET. That's ethylene glycol and terephthalic acid. Nightmare-ish. Okay, so let's figure out our products and reactants. This is my least favorite part because I'm trying to keep track of everything. So let's go ahead and go to the next page and do that again. So reactants and products. First I'm going to do 4 OH bonds and 4 OH bonds. Then I'm going to do 2 carbon-oxygen bonds and 3 carbon-oxygen bonds. 2 C double bond O and 2 C double bond O. 2 benzene and 2 benzene. Thank goodness those cross out. 1 carbon-carbon and 1 carbon-carbon. 4 CH and 4 CH. And this one has an additional CO bond. So that will change this one to 4. So if you take a look at this one, where are we here? I've got my OHs, my C's cross out, these cross out, these cross out, these cross out. Where do I have to put my extra? I feel like I got this came up to 0, but I'm looking at something wrong here. So I have 2 CO bonds. Whoopsie, I copied this down wrong. That should be 4. So now these cross out and those cross out. So all cancel. Our delta H is equal to 0. Phew, we did it.